Can black holes delete the universe? Delete all information that enters a black hole? Well, in this video recommended to us by Decomposed Corpses 5186, we're gonna find that out. Corpses made a video called Why Black Holes Could Delete the Universe, the Information Paradox. This sounds pretty interesting. We're gonna get right into the video. If you're interested in videos like this, reactions like this, make sure you hit the like button on this video and subscribe for more. Let's go.
Black holes are the most powerful things in the universe, strong enough to rip whole stars into atom-sized pieces.
Wild, right?
While this is scary enough, they have an even more powerful and dark property. They might delete the universe itself.
That is such an insane property of black holes, where they just destroy all information that enters it. And well, we're gonna get to find out more about that. Dun, 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 dun. Dun, 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 dun. Corpses.
Black holes in a nutshell.
In a nutshell.
A black hole appears when an extraordinary amount of matter is concentrated in a tiny space. At their center, gravity is almost infinitely strong, and whatever gets...
So the whole concept of singularities was also up for debate in our last reaction video, with part of the community talking about going back and forth. Are they real in the real physical sense?
It's too close is ripped into its elementary particles. Not even light can escape black holes, and so we perceive them as spheres of blackness. If you were to fall into a black hole, nothing bad would happen until well after you crossed its outer border, the event horizon.
Interesting. And nothing bad would happen to you until you crossed over well after the event horizon. I didn't know that. I thought the disk here is super hot, crazy amount of friction. You probably get torn to pieces right here to begin with. But I guess if the black hole isn't actively doing anything at the moment and you cross the horizon, then yeah, this would probably be the case.
You can imagine this as swimming in a river that ends in an enormous waterfall. As you float along, imperceptibly, the stream gets faster and faster, even if you can't see the waterfall yet. You could swim to safety until, without even noticing it, you cross the point of no return. No matter how fast you try to swim now, the stream will pull you towards certain death. Nothing can escape a black hole waterfall once it gets too close. This border completely separates black holes from the rest of the universe. We can't access them unless we're willing to never return.
Who's willing to do that? Willingly.
So there's no way of telling what's really going on inside black hole.
And the thing is, since you're not returning, we'll still not know anything, so...
But we have a few ideas about what's going on right at their very edges. Black holes radiate their mass away, like a hot pot on a stove losing its water as steam.
I wonder how much data we could gather sending probes into a black hole. I wonder what the effects it would be, because even radio signals travel at the speed of light. Would that get delayed as it gets closer and closer to the horizon?
This is called Hawking radiation. Black holes constantly lose an extremely tiny amount of their mass, a process that's unbelievably slow. It will take a black hole with the mass of our sun 10,000 billion years to lose 0.00000001%.
That's insane, right? Insanity.
To its mass. This is happening constantly and unstoppably, and as it goes on, it speeds up more and more. In the far, far future, when
why does it speed up? Does anybody know? Let me know in the comments.
The last star in the universe has been dead for trillions of years, black holes will become tinier and tinier until they evaporate and disappear, leaving behind just a bit of radiation. But this is a problem, because in the process of disappearing, black holes might delete something fundamental.
The universe is no longer available. Sorry about that. YouTube.
Information. 2. What is information? Information is nothing tangible. It's typically understood as a property of the arrangement of particles. What does this mean? Imagine a bunch of carbon atoms. Arrange them in a certain way and you get coal. Arrange them in a different way and you get a diamond. The atoms are the same. What changes is the information. If we make this more complex and add in a few more atoms, we get a banana. Change the arrangement of the atoms, and we get a squirrel.
And all of that gets deleted once you go through that border.
The basic building blocks of everything in the universe are the same and don't care if they're part of a bird or a rock or a cup of coffee. Without information, everything in the universe would be the same. According to
Imagine a universe like
the
that.
theory of quantum mechanics, information is indestructible. It might change shape, but it can never be lost.
In quantum theory, information is indestructible. Really? Very interesting. Well, we're talking in quantum levels. They're already probably part of the smallest components.
For example, if you burn a piece of paper, you get ash. That ash will never become paper again. But if you were able to carefully collect every single carbon atom in the ash and measured the exact properties of the smoke and heat radiating from the fire, you could, in theory, reconstruct the paper. The information of the paper is still in the universe.
Wow.
It's not lost, it's just hard to read. If you could somehow measure every single atom and particle and wave of radiation in the universe, you could see and track every bit of information there is.
Talk about a crystal ball too. You know, with this kind of power, you'd be able to know where everything is, what should happen and what would happen, what will happen, what has happened.
Hypothetically, you could see the entire history of the universe right back to the Big Bang.
It's right there.
And here, black holes trip us up. Information tells us how things are different from each other and what used to be what. Black holes do the opposite. They take different things and make them the same.
Super black.
They destroy information. This creates the information paradox, and this is a serious problem.
Life is a lie.
The information paradox.
Okay.
It's fundamental for all our laws of
Information can never be lost.
physics that information can never be lost. Existing, not existing, without information, everything is relative. When it comes to our understanding of reality, we need absolutes. How could we solve this paradox?
But do we have absolutes for real? For real, when, you know, we're talking about all the crazy properties of the quantum realm, like there is no absolutes really, right? It's all probabilities at that level. But yet, interesting enough, Korkazart said that was a rule of quantum physics. Could someone explain that in the comments? Okay, why would Korkazart say that when it would seem that is more the case, property of general relativity and, you know, larger objects, life-size objects? All right.
There are a few possibilities. 1. Information is lost, irretrievably and forever. This means we have to nix all our laws of physics, throwing out a lot of stuff that's worked very well so far and start from scratch.
Doubt so.
What those new laws of physics would look like, or what that means for us, nobody knows. This is a little frightening, but also kind of exciting. 2. Information is hidden. Maybe a little part of the black hole splits off and forms a baby universe. The information would be transferred into this new, weird place where we could never observe or interact with it, but technically it would not be lost.
Imagine being born into the baby universe.
It's like having a broken hard drive with all your family photos that you could never access. Sure, it's nice that they've not been deleted, but also not very helpful. Or maybe black holes don't disappear completely after the end of their life cycles, but a little piece is left, an information diamond. Like a clown car filled with an infinite amount of information clowns. But there's a third option.
That sounds like wishful thinking to me.
Information is safe after all, not lost or hidden. Perhaps we've just been looking at this whole thing the wrong way. We know that black holes trap information and might delete it later, but we never thought about what they do with it in the meantime. Where do black holes store their information?
Do they store information? I mean, aren't they just ripping things apart? So everything is just, it's like putting something in a blender. You're not storing it in a container. You're completely mashing up and mixing everything.
Cosmic housekeeping. Let's create a black hole with dirty laundry. First, we fill up a room with laundry baskets. The more laundry you want to store, the more baskets you put in the room. But at some point, every single basket is full and the room is completely stacked. Not a single extra sock fits in. The room is at maximum capacity. But if we still squeeze the sock in with a lot of energy and violence, the room collapses in on itself and forms a black hole. But the capacity of the room itself has not changed. Fitting in more stuff or information is still impossible. So what happens if we throw more laundry into it? The room itself gets a little bit bigger to make space for the new information. It turns out a black hole grows its surface by a tiny pixel for each bit of information we throw into it.
Right, which makes sense in terms of seeing all the various sizes of black holes. Okay.
In a nutshell, more information means more surface area. The information gets painted on the surface, similar to what happens when we throw a stone into a pond. After the stone sinks to the bottom, we can't see it anymore, but we can tell that something went in from the ripples on the surface of the pond.
Right, but that's not the same kind of analogy because the pond isn't ripping the stone into dust.
The smallest black hole can store more information on its surface than all the data ever produced in human history. They do this by storing information in a type of pixel that is unbelievably tiny. Black holes are the ultimate hard drive. This is a bit like taking a paperback and turning it into an ebook. Two things that look completely different, but their content is the same. It's just encoded and memorized in another way. Black holes swallowing stars and planets is a bit like transferring a whole library onto an e-reader. This solution is called the holographic principle.
Interesting. What do you guys think about this principle?
But if it's correct, then everything we thought we knew about the universe is wrong. The universe is a hologram.
Oh, the whole universe being a hologram. Okay.
If information is actually stored on the boundary of a black hole, the Hawking radiation has a chance of learning about the information encoded there and can carry it away. So, information is not lost when black holes fade away, and we do not need to redo physics. The information paradox is resolved. But we still have to change our understanding of reality in a fundamental way. If everything that falls into the black hole is stored on its event horizon, that basically means that three-dimensional stuff is encoded on a flat surface.
Dun, dun.
We have a name for this, a hologram. A hologram is like a 3D photo, a flat piece of plastic that encodes a three-dimensional image. A black hole is like a hologram because everything inside it is encoded on its event horizon. A person inside a black hole would experience their usual three-dimensional life. But for us on the outside, they are flattened images on the surface of the black hole.
What? This sounds wild as hell. They would still be experiencing their life. I guess it's like being a programmed NPC in a video game or an AI that's in a computer, but put into, think the Matrix, basically. You're really in a completely electronic world. Code is everywhere, but you experience it like the real world. Hologram. Okay. Interesting.
The consequence of this is counterintuitive, but stay with us for a moment. Black holes are very extreme objects, but they're still bound to the same rules as everything else. So if this crazy duality between 2D and 3D works for black holes, then it might work for the whole universe and you in it. Since a person inside a black hole would not realize that they're encoded on a flat surface, we might share the same fate.
We might already be in a black hole.
Really might be stretched over a flat screen at the end of the universe. The science behind this is complicated and really weird, with toy universes to play with, string theory, and a lot of maths. We'll talk about this more in another video. Regardless of what the true
might have to add that to the list.
Nature of the universe really is, we just know that it's strange and complicated, and we have to do a lot more physics to understand it. But black holes might be key,
if we ever manage to understand it,
to understanding the nature of reality itself.
Okay, so that was the end of that video. I don't know if you went in there with more answers or more questions, after watching this. Are we in a holographic universe? That's insane. Do you think black holes actually destroy all information that enters its horizon, or is it just transformed to another medium? Great question. Me, find it hard to believe that it isn't destroyed, at least in its previous form. The structures, I mean, just due to the simple facts of the extreme gravitational forces that's going to be acting upon every atom that enters that border. It being transformed to another type of information, that's an interesting concept, but I don't know where the basis of that would be. If you enjoy videos like this, make sure you hit the like button, subscribe to the channel, and let me know your thoughts. If you have any other videos you want me to check out, make sure you leave them in the comments. See you in the next video. I appreciate you. Mecca out.